and as part of that I have selected some topics which could be of interest to most of you. And I'm going to talk about the world's largest data warehouse and the technologies that have been used within that. So I'll touch upon a few of them, and then in the last lecture I'll talk about big data analytics and also in general, and then we'll look at extended RDBMS architecture, so which basically extends itself to accommodate some features on relational some features related to data warehousing. We have already done that, but this will be in a slightly different context. So we'll mainly be talking about new data types that are being supported, or it should support, to embrace big data and data warehousing in general. And third topic would be on Hadoop and MapReduce. So this is what I plan to do in this module. So let me begin with the first lecture, world's largest data warehouse. So world's largest data warehouse was built in by SAP in conjunction with NetApp and several other partners, and it was built at the SAP Intel Data Center in Santa Clara, California. And it has 12 petabytes of addressable storage and has been created had been created that has been created for this data warehouse, 12 petabytes, which is huge. And Guinness, it is in the Guinness World Record. It has a Guinness World Record. And another component of this, that is Sybase IQ, is also kind of has a world record has a Guinness World Record. So we'll talk about that as well. And then it is based on the SAP HANA in-memory data platform, and also uses SAP IQ. So SAP IQ was SAP IQ, and SAP IQ was basically built by Sybase, a company which is now part of SAP. And then BMM Soft Federated EDMT, and NetApp SAN storage attached network storage, and contains more than 221 trillion transactional records, and more than 100 billion unstructured documents, including emails, SMSs, and images. And it also contains data from 30 billion sources, including users, smart sensors, and mobile devices. So, and a detailed description of this data warehouse is given in an insider's view to the largest data warehouse by Larry Freeman of NetApp. So what I'm going to do is I'm going to basically talk about SAP HANA in-memory data platform. I'm also going to touch upon IQ, and I'll talk a little bit about SAN storage. Right, so that is what I plan to do. So main focus would be on the SAP HANA in-memory data platform, and also on IQ, which is a database designed which uses the column-oriented data model. Right. So to achieve these impressive results, a data warehouse environment was created by ingesting 3 petabytes per day of synthetic data for 4 consecutive days, a feat that required exceptional storage system performance and reliability. And for that, SAP turned to NetApp SAN storage. So SAN storage is a kind of a storage attached network, so where you have it has its own network on which there are different storage devices that are attached. So so let me begin with SAP HANA, that is the in-memory database, right? And SAP, so most of the figures and other material has been taken from this article by Martin Kittle of SAP HANA development team, and this was published in 2013. So SAP HANA, SAP's in-memory database. So So let me give you some background about this and the kind of work that is being done in this area. So companies are always trying to find the best way to store data in meaningful format so that they can make better business decisions. And since the birth of data warehousing almost 30 years back, numerous innovations in data management have been made, and most of them have been recent in the last 1 decade or so, such as Hadoop and NoSQL databases. So Hadoop also has a database. There is also a database which is built on the Hadoop platform that is called as HBase. And HANA basically stands for High Performance Analytic Appliance, and a platform for processing high volumes of operational and transactional data in real time. So let me give you some details of HANA. So this is what they basically say, that today's technology requires a kind of a trade-off. So whether you want to be broad, to accommodate broad big data and many other data types, and if you are looking for deep, complex and interactive questions on granular data. So if you want these two are your focus, then there are solutions. And if your focus is on speed and simple representation of data, then there are systems which focus on these two. So there is always a trade-off, that is whether you want this or you want this, right? So what HANA basically provides is a comprehensive system which basically delivers across all 5 dimensions of decision processing. So these are the 5 dimensions that they say are involved in the decision processing, or processing that you do, which will help you ultimately in decision making. So they say that HANA is a kind of a comprehensive technology which has all the features that one may require for doing analytical processing. And the second aspect is that it is in memory. So the basic rationale behind that they are saying is that programming so there have been performance bottlenecks that say you must be familiar with this kind of bottlenecks, and every computing system talks about this, that disk I/O is the major bottleneck. And also with the SSDs, that is solid state devices, so this performance of disk has improved many times. And so now they say that the performance bottleneck today is CPU waiting for data to be loaded from memory into cache, so memory to cache. So this is the new bottleneck that they are saying, right? And we need algorithms and data structures that are cache conscious, right? So this is about in-memory computing. And continuing with that, so it says that avoid movement of detailed data, calculate first and then move results. So this has been the kind of motto of in-memory computing. So it says that today's application execute many data-intense operations in the application layer here, right? But it is suggested that you should do it here, not here, right? So high-performance apps delegate data-intense operations to the in-memory computing. So that is what is the shift in paradigm. And again, something about in-memory computing. So it says that don't move the data, right? Move the processing to the data. So that is the major shift. And HANA basically is a SQL DBMS. So if you have worked with a relational DBMS, right? So you would be comfortable working with HANA. And HANA uses hybrid to store, to combine the benefits of row and column-wise data handling. So this is the traditional relational model, and this is the column orientation right? So column orientation does provide certain advantages over row. So what it does is it uses a hybrid model, and some data it stores as row oriented, and some data it stores as column oriented, right? So it is basically trying to take the best of both the worlds. So IQ, as we said, is a column oriented database, and that is part of the data warehouse architecture. And then it also provides a lot of safety, and so there are something called as save points and logs, and and they provide this through what is called as a persistency layer, and which helps in making your data safe, and there are regular backups and restore operations are possible. And it speaks SQL and MDX. So MDX is multidimensional expressions, which were developed by Microsoft way back, I think in 1997 or so, and then it has been adopted by many of the relational database vendors. And SQL and MDX, so both can be used against HANA, and use Excel as a front end if you like. So if you are comfortable with Excel, so it also gives you an interface for Excel to work with. So this is about using data. So we have talked about storing data and using data, and then so that is more or less about HANA. So HANA basically, as I said, it's an in-memory computing platform, or it's an in-memory database which looks like a relational model, and it works like a relational model. And if you know SQL, then you'll be comfortable, and if you know MDX, then it is even better, right? And it uses both data models like row oriented and column oriented, and that is mainly about HANA. And again, if you want to read more about HANA, then I would refer you back to the article that I mentioned right at the beginning of the lecture. So now let me turn turn towards the SAN storage. So development of storage hardware, which was nearly 2 tons, occurred over several I missed out on something, so this should be several days. Right, so NetApp E-series storage was used, so was deployed for the majority of the data to the tune of 5.4 petabytes of physical storage capacity across 20 storage arrays and 1800 3 terabyte NL SAS disk drives. Right, so this is what was the storage architecture, and the record of 12.1 petabytes of total addressable capacity was achieved thanks in large part to an SAP in-system data compression rate of 85% for a mix of 50-50 for structured and unstructured data. And NetApp E-series storage was selected for the project because of its proven availability and its ability to handle the project's data ingest requirement of 34.3 terabytes per hour, so which is phenomenal, right? And the E-series SAN used a fiber channel fabric to support SAP IQ's large and varied data needs. So SAP IQ, so as I said, SAP IQ is part of this data warehouse, so the data was all stored in the SAN network, or the SAN storage. And then a few things about SAP IQ. So it's a highly optimized RDBMS built for extreme scale big data analytics and data warehousing. It was developed by Sybase, which is now a SAP company, and SAPK holds the Guinness World Record for the fastest loading and indexing of big data. And it's a column-based petabyte scale relational database software system used for BI and data warehousing, and also for data marts. So its primary function is to analyze large amounts of data in a low-cost, highly volatile environment, highly available environment, right? So availability should be high and the cost of processing should be low. and SAP IQ is often credited with pioneering the commercialization of column store technology. So the popularity of the column-oriented storage was or data model was made popular because of the SAP IQ. And then let me just touch upon Hive, so which is a data warehousing platform built on top of Hadoop. So I wanted to talk about it later also, but I think I'll just Hadoop since we have not touched. So, but it is okay. Let me just give you what is Hive. So, a data warehouse infrastructure built on top of Hadoop, and it enables easy data summarization, ad hoc querying, and analysis of large data sets stored in Hadoop files, and provides a mechanism to put structure on this data. And it's a simple query language, HiveQL, which is again based on SQL, which takes lots of features of SQL, and which enables users familiar with SQL to query this data. And HiveQL allows traditional MapReduce programmers to traditional MapReduce programmers to be able to plug in their customer mappers and reducers to do more sophisticated analysis, which may not be supported by the built-in capacities of the language. So you can plug in your MapReduce code, or you can say mappers and reducers. MapReduce code is nothing but mappers and reducers, right? So you need to define a map function and a reduce function, right? So this is something about Hive, and it provides tools to enable easy ETL and and a mechanism to impose structure on a variety of data formats. That means it can interface with multiple data formats or data sources, and access to files stored either directly in the HDFS, which is the Hadoop distributed file system, or in other data storage systems such as Apache HBase, which I said is a database again developed at Apache on top of Hadoop, right? And query execution is via MapReduce, right? So this is about Hadoop, Hive, which is a data warehousing platform built on top of Hadoop framework. And with this, I come to the end of this first lecture. So where I talked about the world's largest data warehouse, and it is recorded in the Guinness World Record Book of Guinness World Records, and it revolves around HANA and the in-memory data computing platform, and it also uses IQ, SAP IQ, and of course the storage, the SAN storage developed by NetApp. So with this, I wind up this lecture. In the next lecture, I'm going to talk about big data analytics and the support RDBMSs must incorporate or must build to work with big data, and I'm going to talk about Hadoop and MapReduce.